So for page 4, you see the problems at the top, number 7, 8, and 9. The first one I'm kind of inclined to do by hand because it's not too crazy. You're only going from 3 to 6. But then after that, you start understanding, okay, well, maybe technology is a good way to go. So if I pop in, the index is k here, so I'm popping in a 3 for k. So I'd be looking at 3 times 3 minus 2, and 4 times 4 minus 2, 5 times 5 minus 2, and 6 times 6 minus 2, and then adding the results together. Alright, so that's 3 times 1, which is 3. 4 times 2, which is 8. 5 times 3, which is 15. And 6 times 4, which is 24. So we got 11 plus the 15 is 26, plus 24 is going to be 50. And then just because I can't help myself, I do a quick double check. So again, alpha window, option 2. You could put the k in, nothing wrong with that. K equals 3, going up to 6, and then popping in a k times k minus 2. And it gives you the 50, so we know we're in good shape there. Now again, second enter. I prefer second enter, but you could hit the up arrow on TI-84s. I prefer the second enter approach for the same reason all older people prefer things. Just that's the way I learned it when I was growing up. So there it is. Force of habit. And it also gives me something to talk about while I'm buying myself time to type stuff in. So for number 8, I'm just going to type it in because I am not writing out 2 times 1 minus 3, 2 times 2 minus 3, 2 times 3 minus 3, 2 times 4 minus 3, and so on. Right? So I'm just popping this right in to the calculator and just having it spit on out that 195. All right. And then we'll do the same thing with the last one, except it's going from 1 to 10. I get a little paranoid with the parentheses, and I'm using k's instead of i's, so that's not really a big deal. But I'm gonna put a set of parentheses around the entire subject of the summation, and then I obviously will have the parentheses for the I squared plus 1 part of it. Okay, so k squared plus 1 in this case, or the calculator's case. Oh, see that can't be good. So let me clean that up. That ginormous closed parens can't be appropriate because there's no ginormous open parens to pair it with. All right, so just doing a quick double check, hit enter, 3080. All right, so a lot of calculator work, and that's totally fine. It's when you get to something like numbers 10 and 11, 12, and so on, and you see the detailed approach to how you would do some things in the calculators. I'll run through that in a minute because it's kind of cool. It's a little bit different from what I've been showing in the last couple of videos, but it's useful. But let's take a look at these examples first. All right. So when you're writing in sigma notation, summation notation, however you want to say it, all you're doing in your expansion is you're looking for the thing that varies. And sometimes it's more than one thing. All right. So in this case, I see the only thing that varies is the second term of the denominator. Everything else stays put. So when I'm structuring my summation argument, the 5 and the 1 plus are going to stay put. That's going to be the same in every case. I know I'm adding, if I can get a summation symbol, those additions are spanning from an index value, I'll use I for index, of 1. Where does it start? Where does it stop? It goes from 1 to 15. And that's it. Right? Now, some of them are going to look fairly complicated, but if you can get at the idea of, okay, what's changing and what's remaining the same, then it gets a lot easier. So you see here, these are changing. All right? So it's going from 1 to 4, everything else is remaining the same. So a summation going from 1 to 4. We got big old square brackets, 1 minus some index I over 4 squared. And again, as long as it's going from 1 to 4, you've covered yourself. All right. There's no reason to think that the trend deviated, because the dot 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 indicates that the trend that you have observed is going to continue. All right. So there's no reason to think that there's any deviation there. All right. Now, number 12 is different story in terms of, I mean, we're going to use the same approach, but it's different in terms of whether it's obvious like your final answer. Can you just pull the information out? In some ways, yes. In some ways, no. All right. So the first thing I notice is that we have a 1 minus, we have a binomial squared, and we have a 2 over n in all cases. And by all cases, I mean both cases. All right, so I can jot that information down, but I do notice a difference here. 2 becomes 2n. All right, so I'm going to leave that off for a sec. All right, so it's just a question of figuring out, well, what on earth is happening there. All right, so we will have a summation. That summation is going to have some index that we're going to call I. It could start at 1, it could start at 0. We don't know. We'll figure that out in a sec. All right. So now it's just a question of, okay, well, what would I have to be in order to completely disappear? Well, there's a few different possibilities. All right. Well, the 2 remains there. All right. So keep that in mind. All right. So the 2 remains there. That 2 is part of it. There must have been something after that 2 that along its journey became, in its final step, became some value n. All right. So there is a 2 there. So we can hang on to that. So if we think about this, we can say, all right, well, maybe that was a 2 times 1. I mean, because it's not like 21, it's 2 times something, right? So 2 times 1 would give you a 2. That makes sense. All right, so let's make that assumption. If that's the case, 2 times 1, where 1 is taking the place of the I, it would have to indicate that this was 2 times I. Now what we need to do is verify that that's actually going to play out the rest of the way. All right. So, I mean, we could expand this whole thing out if we want, but let's just focus on the sum from I equals 1 to some maximum value, but I. All right, just that part of it. If that's the case, we would start with a 1, it would change to a 2, then a 3, then a 4, then a 5, and then eventually it would get to whatever that top number is, whatever this top number is. What if that top number is an unknown large value that we call n? Then this would max out at n. Right? So if that is the case, then what we have here is a span of values that go from 1 to n, because they didn't give us much more beyond that. They didn't tell us that it was, 2, then 4, then 8, then blah, blah, blah. it went from the first term to the last term all in one shot. So it's kind of aggravating, but it gives us a little bit of a, you know, an opportunity to think it through, all right? But if we make that assumption, then there's no reason to think that this wouldn't be an n, all right? So if the first value is a 1, then 2 times 1 becomes a 2. All right, the second, the third, the fourth, the fifth, and all that, there's no way to verify it, but the very last value would be 2 times n over n, which checks out. All right, so this is a reasonable expression to represent the sum that's indicated in the given expression. All right. Now, for the process at the bottom, how to do summations on your calculator in mode, set the fourth line to sequence and all that. So this is more for the TI-80 TI-83s. It also works in TI-84s, but it is a way of sort of building what you see on your screen here, and I figured it's worth showing because you have you'll have a need to come up with just the sequence part of it, and this gives it all in one shot. So in mode, see, you have an option for sequential or simultaneous. Oh, I'm sorry, wrong thing. Function, parametric, polar, or sequence, not sequential. The other thing, I just had a brain cramp. The other thing is to graph a function, either one at a time or at the same time. All right. So if you go in here and set it to sequence, then it's going to change your y equals menu, which it's a bridge we'll cross later. All right. But in second stat, you have ops and you have math. All right. If you go to math, you see an option for sum, which is option 5. Second stat ops, also 5. Sequence, this allows you to put in an expression that'll give you the array of values. This is kind of more important at this point, but I will show you how you could use it to verify your answers. Let's just do number 7. All right, the expression is k times k minus 2, where the variable is k, and we're going from 3 to 6. The step is indicating what you want to go by. 1s, 2s, 10s, 0.1s. We're going by 1s. So then you paste that in there, and you have this whole line of, for lack of a better word, code, the sum of the sequence, and it'll spit out the 50. But let me show you what would happen if you took the sum away. So it's just a sequence, and I'll get that closed paren off at the end there. It gives you the array of values that make up the sequence. All right, so that's really what we need this for, and that's really the value behind this. But I figured, why not show you the whole shebang all at once too. So another thing we can do is, now that we have our calculator in sequence mode, we can go into y equals. We can type in n min, you can leave it 1. You can put it at the actual minimum value of your function, in this case sequence, which is 3. So I can do that. I can make this a 3. And then type in, they use n's as the index values in the TI. So I would type in n times n minus 2. Now you see the xt theta n key. Because we're in sequence mode, not function mode, it would bring up an n when we hit that value. So n times n minus 2. And then you can look at the graph, but if we just want the sequence values, all you'd have to do is go to the table second graph, and you would see here it gives error for everything that's irrelevant. Starting at the index of 3, it gives a result of 3, then 4, then 5. Then 4, 4, 5, and 6. It gives you an 8, 15, and 24 respectively. All right, it gives you more than we need, but it gives you the values we do need also. All right. So that's another tidbit related to the calculator. So let me quit out of here. I'm also going to put my calculator back into function mode because we're going to need it to be in function mode for a lot of other things. So let me do that and quit on out of here.